Today we are in Unit 8, Day 2, focusing on what we call inverse trig ratios. So first thing, I gave you a few questions just to kind of think about that we're going to use these skills a little bit later on in the lesson. 1 and 2 are just both proportions. We talked about these yesterday. In a proportion, we know the cross products are equal. So we're multiplying 3 and 4, and we're multiplying 7 and x. So we have 7x equals 12. We solve that. And we end up with 1.71. Same thing on the next one. Again, we're going to set the cross products equal. We have 8x is equal to 60. And we end up with x is equal to 7.5. Taking a look at question 3, one issue that many of us have is just identifying opposite, adjacent, and hypotenuse. We'll recall the hypotenuse is always across from the right angle. So in this case, we know the hypotenuse is radical 5. They want to know the leg opposite of angle B. Here's angle B. Sometimes it helps if you lay your pencil through that angle, and then the side that it is pointing to would be considered opposite, which in this case is 2, which means the leg that adjacent to it would be that side length of 1 or CB. So yesterday our focus was on finding a missing side. Today we're going to look at a situation. If you jump down to number 4, we've been given 2 of the sides, but in this case we're looking for the measure of angle R. So this is called inverse when we're looking for the signs. Let's kind of underline that for you as well. So first thing, let's go ahead and show you how do we find those inverse measures on your calculator or on your table. In this particular case, we're looking for an angle, that has a tangent equal to 0.3640. So if you notice, here's the tangent button. Right above it is tan -1, which is the inverse. So I'm going to hit second, tan inverse of 0.3640. And we end up with approximately 20 degrees. Let's take a look at the next one. Same thing. I'm looking for an angle that has a sine ratio of 0.9339. So again, here's my sine button. We're going to do inverse sine of 0.9339. And again, it gives me a 69-degree angle. Same thing on the last one. I'm looking for an angle that has a ratio of 0.6428. So again, I find the cosine, inverse cosine is sitting right above it, of 0.6428, and we end up with a 50-degree angle. Now, if you don't have your calculator, you might have to look up online a table. I'll show you how one of those works, and I'll show you the online calculator as well. So for example, this first one, we're looking for what degree measure ends up giving me a trig or a tangent ratio of 0.3640. So I'm going to go to the tangent column, and I'm scrolling down, and I'm looking for the number in here to be 0.3640, which is right here. And then if I go back here, I can see it's a 20-degree angle. Same thing on the next one, let's skip down, 0.9339 for the sine. So I'm going to go to the sine, I'm looking for 0.9339, which is pretty close to here. If you go back, it ends up being a 70-degree angle. So in this particular case, we're looking for the measure of angle R. And if, again, relating to what we did yesterday, if I'm looking at angle R, this would be the opposite side, this would be the adjacent side, which means I know I'm using tangent because that is TOA, which involves opposite and adjacent. So we have the tangent of R equals 47/41. And really, this equation is almost identical to this one. The only difference is this is a fraction instead of a decimal. But I'm still looking for an angle who has a tangent ratio of 47 over 41. So again, take a look at what we have. The measure of angle R is inverse tan of 47 over 41, and they're even showing you how to plug it in your calculator, and I'm going to show you as well. So, let me put my calculator right beside the problem. I'm doing inverse tan, and I need to tell it what that decimal is, which in this case they've given to me as a fraction. So I'm typing in 47 divided by 41, and we end up with 48.9 degrees, which is the same thing they got here. Real quick, if you don't have a calculator, you don't have a table, you can go Google scientific calculator. Let me show you how this particular problem would work. First of all, this is the normal mode it's in. We want to do inverse tan, so I'm going to click on the inverse button, then I'm going to type in tangent, and now I'm going to type in that 47 divided by 41, and it gives me the same measure that I did on my calculator. Now, they use the symbol arctan. Arctan is the same thing as inverse tangent. Continuing on the back side. So again, these four here are simply looking for an angle that has 0.4848 as its sine ratio. So this is nothing but pure calculator work. I'm going to, again, hit inverse sine. Let's see if I can get it to, there we go, of 0.4848, and we end up with approximately a 29-degree angle. Next one, we're looking for, again, when is the sine equal to 0.6561? Inverse sine of 0.6561, we end up with a 41-degree angle. Let's move on to the next two over here. Again, inverse sine of 0.6293. We end up with a 39-degree angle. And the last one, inverse cosine of 0.6157, and we end up with a 52-degree angle. Now, all of those are easy to solve because I know what trig function I'm using. So now if you take a look at the next examples, we don't know what trig function we're going to use. So similar to what we did yesterday, that's going to be the biggest issue. But just as I did yesterday, I'm going to go through and label those opposite, adjacent, and hypotenuse sides. Taking a look at number 5, this is the angle that I've been given. This is across from the right angle, so this is my hypotenuse. This side is next to the angle that I'm looking for, so that is adjacent. Keeping in mind SOHCAHTOA, the only trig ratio that involves adjacent and hypotenuse is cosine. So I'm going to set up a cosine equation, and I'm just going to label this to be x. So I'm looking for when is the cosine of x equal to 32 over 35. So again, anytime I'm looking for the angle, I'm going to use inverse cosine. So again, inverse cosine of 32 divided by 35, and we end up with approximately 24 degrees. 6 and 8 cut off. Let's go down to number 7 and then we'll come back to those. So same thing on number 7. I have to go figure out what trig equation I'm using. Again, this is hypotenuse. Again, this happens to be adjacent, so actually it's the exact same setup as number 5. We're doing cosine of x has to equal 30 over 31. So again, on my calculator, I'm going to doing inverse cosine of 30 divided by 31, and we end up with 15 degrees. Alright, not sure what happened, but my paper kind of got cut off with some of the examples, so I went back to redraw them. Let's go down to number 9. I'm looking for this angle here. I'm going to label that to be x. If you notice, I don't have the side across from the right angle, so I don't have the hypotenuse. This would be the opposite, and this would be the adjacent. So again, if you go back up and look at SOHCAHTOA, the only trig function involves opposite and adjacent is TOA. So I have tangent of x equals 3 over 6. So again, I'm looking for that angle measure, so we're going to go do inverse tan of 3 divided by 6, and we end up with 27 degrees. Okay, moving on to the second column. So take a look at number 6. Number 6 again, we have the hypotenuse in this case. And again, we have the adjacent. So these are actually similar to both 5 and 7. The only trig function that involves adjacent over hypotenuse would be cosine. So again, we have cosine of x equals 39 over 46. We're looking for that angle, so again, we're going to go type in inverse cosine of 39 divided by 46, and we end up with x is equal to 32 degrees. Okay, I'm going to stop it for just a minute, give you a second to work out 8 and 10, and then we'll hit that last one together. So I finished up 8 and 10 for you. Again, labeling opposite and adjacent. Both of these happen to end up being tangent as well because neither one involved hypotenuse. Let's take a look at the last one. It wants me to find each missing length and angle measure. Well, I have a right angle here, I have 62 degrees here. Remember, the sum of the angles has to add up to 180 degrees. I'm going to go ahead and label these sides for myself in angles. So that means I know the measure of angle B has to equal 180 minus 90 minus the 62, and we end up with 28 degrees. Now we need to go find the two sides. I'm going to label this side right here to be x. So the first thing I'm going to go ahead and do is solve for x. And it doesn't matter which angle I use, I'm still going to ultimately end up with the same answer. So I'm going to use the 62 degree angle. This is opposite, this is adjacent. That means I'm going to do tangent. So I have tangent of 62 degrees equals 28.4 over x. So this is actually what we did yesterday. In this case, I'm looking for an angle. I'm still going to cross multiply. We have x tangent of 62 equals 28.4. I'm going to divide by the tangent of 62. So we can, again, pick up our calculator and type everything in. I see 28.4 divided by the tangent of 62, and we end up with 15.1 for that side. Alright, one more side to hit, and that's this side right here. We'll label this side to be y. In this case, I'm going to use the 28 degree angle. Again, just to show you it doesn't matter. This is adjacent, this is hypotenuse, which means we've got a cosine. So, cosine of 28 degrees equals 28.4 over y. Again, we're going to cross multiply. Y cosine of 28 degrees equals 28.4. I need to get y by itself, so we're going to divide by the cosine of 28. And again, we can plug everything in our calculator. 28.4 divided by the cosine of 28, and we end up with 32.2. So most of tonight's assignment, you're going to be looking for the angle. Anytime you're looking for the angle, you're using these inverse buttons, which are all above the sine, the cosine, and the tangent. If you have any issues or questions, feel free to post a question on the discussion board or send me a message.